Hello students, now let us continue with the problems on bilinear transformation. Here is one problem. Find the bilinear transformation which maps the points z is equal to 1 I minus 1 into w is equal to I 0 minus I respectively, and also find the image of mod z less than 1 under this transformation. So how will you solve this problem? First of all, you are going to work for the bilinear transformation which is mapping these points to these points. Okay, so the image under that transformation for the points is given to you, yes, and you are going to work for the transformation. After that, you are going to find the image of this mod z less than 1. So what do you mean by mod z less than 1? It is nothing but the interior part of the circle, yes, with the center as the origin and radius 1 units. Only you are going to leave the boundary points, the interior points of those of that region, which is a circle with center as the origin and radius 1 units, except the boundary. Okay, so we are going to find the image of those points under that transformation. Okay, so let's see how to work for this. So it's very simple. You just have to write the standard form of a bilinear transformation. I hope you all remember, which we have learned before in my previous class. So we have got w is equal to a into z plus b divided by c into z plus d. This is the standard form of a bilinear transformation, okay, where we have to work for the constants a, b, c, d. Okay, now we just have to work for the constants a, b, c, d. Okay, so to work for them, what we will do is, yes, we take the given things and we just substitute the values of z and w in this given standard transformation. Okay, so let us do the same now. So when z is equal to 1, if z is 1, w is I is equal to a plus b divided by c plus d. You get, you just put z is equal to 1, you get that. Okay, or this implies c into I plus I into d is equal to a plus b. Or further, if I just want to rewrite that equation, it will be a plus b, 1 minute, a plus b minus ci minus id is equals to 0. Call this as equation 1. Similarly, if z is equals to I, you are having w is equal to 0. So you get this equation as 0 is equals to w is 0. So substitute the value for z. It is a into I plus b divided by c into I plus d. Okay, or when you further simplify this, you will have ai plus b is equal to 0. Call this as equation 2. Okay, similarly, if z is equal to minus 1, w is minus I, that is equal to, you are having w is equal to minus I when z is minus 1. So minus a plus b divided by minus c plus d you will get. Or when you further simplify this, you will get I into c minus I into d is equal to minus a plus b. Or you further simplify this, you have minus a plus b minus ic plus id is equal to 0. Call this as equation 3. Okay, so you have got 3 such equations. Okay, so what I will do, I will consider equation 1 and 3. You have all 4 constants appearing. And you see, try to simplify it. Okay, so as you see, if I add the 2 equations, so adding equation 1 and 3, you will have plus a minus a 0 plus b plus a minus a 0 plus b minus b, sorry, plus b 2b minus ci minus ci. So you have minus 2ci plus id minus id plus id, it is again 0. So that gets cancelled, you have only this. So you further, if you simplify this, it will be b minus ci is equal to 0. Okay, call this as equation 4. Now equation 2 and 4 we can solve. Okay, if I want to write equation 2, how can I write it? I can write it as ai plus b. Since there is no c coefficient, I can write 0 into c is equal to 0. Okay, so consider equation 4. Since a is absent there, so I can write a 0 into a plus b minus I into c is equal to 0. So I have got 2 equations with 3 unknowns. Okay, now I can solve for their corresponding or proportional values of a, b, c. I can find by just proportional values I have to find using these two equations. Okay, so using these two equations we'll find the proportional values for A, B, C. How? By cross multiplication method. So what is that cross multiplication method? We write the constants A, the unknown A divided by the determinant is equal to unknown B, we write it as minus B divided by the determinant is equals to unknown C divided by the determinant. So always remember, only with B or the middle term ABC standard form we have written, there we have followed the pattern, and the middle first variable or first unknown we'll write it as A as it is, but the second variable or second unknown we are writing it as minus B. So this already we have learnt before while we were working for I hope you all remember, while we were working for eigenvectors in first semester. Okay, so we have solved it already, but anyway, this is the cross multiplication method. What we do, we write first unknown A divided by the determinant is equal to unknown B, we write not B, we write it as minus B, okay, divided by the determinant, okay, is equal to unknown C divided by the determinant. Okay, so now if I replace, if I just write B in place of C, C in place of B, then minus C divided by the determinant. Okay, always remember that it all depends on the order of that coefficients. Now to write the determinant or to write the denominator for A, we'll leave the column of A. Look at the equations. Okay, just forget about this. Okay, write the coefficients of the other two unknowns in the determinant. The coefficient for B you are going to write here from the first equation, and follow it in the same row the coefficient of C, 0. Okay, lower part of the determinant, that is the next row for the determinant, will be what? The coefficient of B from the second equation followed by the coefficient of C in the same equation, that is minus I, like this. Similarly, the coefficient for B, we writing the denominator for minus B, we consider only the coefficients for A and C. So for now, from the first equation, it is the coefficient of A as minus I, coefficient of C 0, coefficient of again A 0 in the second equation. Second equation, the coefficient of C minus I, like this. Similarly, the coefficient of, the denominator for C, how we'll write? We neglect C now and only consider the coefficients for A and B. From the first equation, I, B 1, second equation 0, second equation 1. Okay, now let us work for, and we equate all of this to some constant, say K. Okay, so this will not give you the accurate values, but they will give you the proportional values for ABC. Okay, now, and through which you can solve easily. Okay, so now A divided by, if you solve the determinant, it will be minus I minus 0, so minus I as the denominator for A, minus B divided by minus I square you will get, minus C divided by I is equal to K. Or if you work for this, A will be equal to I minus I into A. If you equate the first ratio with K, look at this, A divided by minus I equated to K, you will get A is equal to minus IK. Similarly, minus sign gets cancelled, is it not? Yes, look at this, it will get cancelled. B divided by I square you are having, so B will be equal to I square into K. What is I square? I square is minus 1, so you will get minus K. Similarly, C is what? I into K. You have got the proportional values for ABC now. You only have to work for the proportional value of D. For that, we have to consider equation 3 or equation 1. You can consider where all 4 variables are considered, or where the equation consists D. Okay, you see equation 3 and equation 1 consist D. So I am considering equation 3 here. So the value equation 3 is minus A plus B minus IC plus ID is equal to 0. From equation 3 we have this. Okay, so we will substitute the values of A. If I put A as minus IK, it will be plus IK. Value for B is minus K, so it becomes minus K here. Value for C, it's IK. I into I, it makes it I square. I square is minus 1. Minus 1 into this minus sign, it becomes plus K. Plus ID is equal to 0. Plus K minus K gets cancelled. You will get I into D is equal to minus IK. I gets cancelled. D will be minus K. So this is the value for D. Okay, this is the value for A, value for B, and value for C. We have found all the values. The bilinear transformation W is A into Z plus B divided by C into Z plus D. Put the values for A. Value for A is minus I into K, Z plus B value, it's K divided by, value for B is minus K, minus K you get here, divided by C value, it's I into K Z, value for D is minus K. Now I can take minus K common from the numerator. I'll be left with 1 plus IZ divided by, I can take K common, minus K common from the denominator as well, so that we are left with 1 minus IZ. Okay, plus minus K gets cancelled. The required transformation is 1 plus IZ divided by 1 minus IZ. So we have got the required bilinear transformation W, which is 1 plus IZ divided by 1 minus IZ, which is mapping these 3 points to these 3 points. Okay, so half work is done here. Now next part of it is finding the image of mod Z less than 1 under this transformation. So let's proceed for that now. Okay, so for that I will consider my obtained transformation. So from our solution we got W is equal to 1 plus IZ divided by 1 minus IZ as the bilinear transformation, which is mapping those points to those. Okay, now just let's continue with the mod Z less than 1, its image, how will it be? Okay, for that I will just separate my Z from here. Okay, let us separate our Z from here. So get this to the left hand side. It is 1 minus IZ into W is equal to 1 plus IZ. Okay, so W minus IZW is equal to 1 plus IZ. Get this IZ to the left hand side and bring this W to the right hand side. So you will have minus IZW is equal to 1 minus W. Okay, now I can take IZ common with a negative sign. 1 plus W will be left inside, which is 1 minus W here. Okay, so I want Z from here. It will be 1 minus W divided by minus I 1 plus W. Okay, now you can work for what is 1 divided by I. 1 divided by I is minus I. Okay, so let us work for that. So if because here it is 1 minus W divided by 1 divided by, I'll take this minus sign to the numerator. Look at this. Okay, minus sign to the numerator. 1 divided by I you are having, and 1 plus W you are having, like this. Okay, now 1 divided by I is minus I. So let us write it. So minus into minus I, 1 minus W divided by 1 plus W. Minus of minus plus I into 1 minus W divided by 1 plus W. This is what you get. Z is equal to. Okay, now you are speaking for mod Z less than 1. Okay, we want mod Z less than 1. Okay, so Z is equal to this. So mod of this less than 1 means what? It will be, yes, let us substitute the value for Z here. Okay, so it will be mod of I into 1 minus W divided by 1 plus W. Its mod should be less than 1. Yes or no? If Z is equal to this, we have got, according to the given obtained transformation we have just obtained, it is this, right? So given question is what? Mod Z is less than 1. So if Z is equal to this quantity should be less than 1, right? So what is mod of Z1 divided by Z2? It is nothing but mod Z1, it is equal to mod of Z1 divided by mod of Z2, right? So by that property, the two are complex numbers. And what is mod of I? Mod of I is 1, right? So mod of I is also 1. So I can just work for this. So it will be mod of 1 minus W divided by 1 mod of 1 plus W is less than 1. I can write, or take it to the left hand side. 1 minus W, its mod, is less than 1 plus W, its mod, right? According to this equation, right? Now if I put W is equal to U plus IV, let U be the real part and V be the imaginary part. So we are writing the W as 1 U plus IV already here. So the same we are following here. So what do you get? 1 minus U plus IV its mod less than 1 into it is, so it will be okay, 1 into that, okay, and 1 into this will be mod, okay, please complete it, you will get mod, please, I left to complete the mod there, please make a correction there. So it is mod of 1 plus u plus iv. Okay, what is mod of this? What is mod of this? It is nothing but, yes, if w is equal to u plus iv, mod w is root of u square plus v square, right? The real part its square plus the imaginary part square its root, that gives you mod. So here we have to work for mod of this quantity, okay? The real part is 1 minus u, imaginary part is minus iv. So the modulus of this is root of 1 minus u whole square plus v square. Won't you get this? Divided by mod of this, it means it is 1 plus u whole square plus v square. Since the two roots are equal, I can write 1 minus u whole square plus v square is less than 1 plus u whole square plus v square. Now v square gets cancelled, you see, you can cancel that, okay, and you are left with 1 minus u whole square less than 1 plus u whole square. Now simplify this. What is 1 minus u whole square? It is 1 plus u square minus 2u is less than 1 plus u square plus 2u. Now 1 square, 1, everything gets cancelled. Now minus 2u is less than 2u. Or you can take this to the left hand side, or say this equation as minus 4u is less than 0. Yes or no? Take minus 2u to the or take 2u to the this side, it becomes minus 2u. So minus 2u, it becomes minus 4u less than 0. Okay, you have to take it like this. Then minus 4u is less than 0. Now minus 4 is already less than 0. Okay, minus 4 I can, or you can write this as, the other way of writing it is nothing but 4u is greater than 0. 4u is greater than 0, right? Minus 4u is less than 0. The other way of saying is what? Quite by this implies what? 4u is greater than 0 logically. So therefore, yes, mod z, if 4u is greater than 0 means what? Can you tell me what is 4u greater than 0? 4 is already greater than 0. So this implies actually 4 is anyway constant. Okay, so u must be greater than 0. U is greater than 0 means what? This is my w plane, right? So u axis, v axis, okay, this is minus u, this is minus v, right? U is greater than 0 means u is only greater than 0 over here, right? So mod z less than 1, mod z less than 1 is here actually, I'll show you. Say this is radius 1, okay, this is the origin center, okay. So you are mapping under this bilinear transformation. What is happening is all the points inside this circle, not the boundary points, only the points inside the circle, they are mapped to the real axis of the w plane. Because look at this, u is greater than 0, and that too not real axis but positive real axis of the w plane, because u is greater than 0. When you put z as less than, mod z less than 1, if you consider all the interior points, the image of those interior points of the circle mod z less than 1 is mapped to the positive real axis of the w plane. That is all this entire line in the positive direction. Okay, this gives you the complete solution for this problem. If you have any doubt, you can ask me in our WhatsApp group. It's very simple. You just see these are all simple steps. Okay, so you can just follow them. Okay, continue in my next session, next class.